So sine, cosine and tan will, and at least at the beginning, be primarily used with right-angled triangles to indeed work out sides and angles. However, sine and cosine can actually be used with any kind of triangle, again to find sides and angles. However, in these cases, slightly different methods are going to have to be used. These methods will be called the sine and cosine rules. Let's just look at a triangle here where we have sides A, B and C, and then the angles are labelled similarly A, B and C, with the side and its opposite angle being given the same letter, just then differentiated by either a lower or uppercase. With this then, the first sine rule would state that if you were to just take any of the sides, such as say A, and divide it by the sine of the angle A, so the opposite angle, this would give you the same value as a different side divided by the sine of its opposite angle, and so the same with the third pairing. So if, say, we had two of the sides and one of the angles and we wanted a different angle, we could rearrange these formulas to get sine B on its own, and then just get B on its own by doing the sine inverse of everything that was thus on the other side of the equal sign. We'll be doing an example of that in a second. Just to go through the other rules though, the second sine rule, there are two, they're both called the sine rule just because they both contain sine. This one instead is to work out the area of a triangle. So we'll say that the area equals half of AB sine C. So half of two sides that meet at a point times together times the sine of the angle that's between them. It has to be two sides that meet, and it has to be an angle between them. And lastly, the longest of these formulas is the cosine rule, so called because now that's including cos. This is that a squared would equal b squared plus c squared minus 2bc cos A. Now, this can be rearranged to make the angle A the subject, but for now this is maybe the usual form we'll see it in. So this is just saying, to be clear, that a given side of the triangle squared is going to equal one of the other sides squared, add the other side squared, minus 2, times those two other sides times together, times the cosine of the angle that's opposite what you're after. Alright, so if those are the rules, let's actually go through some examples so we can see how they're used. If we were to just draw out some triangle, let's say this angle here is 15, this has a side length of 11 centimeters, this has a side length of 9 centimeters, and we don't know this angle here, x. Well, so we know two sides, we know an angle, we want another angle. For this, we're going to be using the first sine rule. So we can say that 9 over the sine of 15 is going to equal 11 over the sine of x. In order to rearrange this to get x as subject, therefore, we're going to have to get this whole sine x out of the denominator. Think about how we rearrange formulas. How we're going to do it in this case is to times up the sine x onto the side. So it becomes sine x times 9 over sine 15 equals just that 11 that's been left on its own. Now then, though, to get the sine x on its own, you need to divide by this fraction. So now it'll be 11 divided by the 9 over sine 15. And this you can just put into a calculator to get approximately 0.32. This isn't good enough, however, because that's not actually the value of x, that's sine x. So to get x on its own, we'll need to do the inverse sine, so shift and then sine on your calculator, of what was on the other side of the equal sign. We've rounded here to 0.32. Do try to keep as many of the decimals on your calculator as possible. It will just make your answer more precise. But from this, so doing that sine inverse in the calculator, you'll get an angle there of approximately 18.4 degrees if, say, we're doing it to 3 significant figures / 1 decimal place. Okay, well, if that's then the first sine rule, let's try for the second. And we'll just have to clear up our space here. And also what I'm going to do is I'm going to remove this 9 and this angle here, just so we don't have any conflicts of numbers. Because now what I'm going to do is label this as 13. Because, as I said before, for the second sine rule, for the area, we need two sides that meet at a point, and you need to know an angle between them. So here, our 11 and our 13, they meet at a point, and the 15 is between them. So, for our area, it will simply be half times 11 times 13 times the sine of 15, and that should get you an area of approximately 18.5, and this will be centimetres squared because it's centimetres. Okay. Lastly then will just be the cosine rule, which we don't actually need to change our diagram for because we already have just two sides and an angle and a third side that we want here. For the sake of consistency with the formula, I am just going to label it A so we're clear on what goes where. So with this in mind, we can therefore say that A squared is going to equal 11 squared plus 13 squared minus, I'm going to do this bit all in brackets, 2 times 11 times 13 times the cos of the 15. All of this you can just put straight into your calculator, giving us an A squared value of approximately 13.7, which, if you can just square root, will give you a line length here of approximately 3.7 centimetres. We can clearly see that my diagram is not to scale, therefore, but that's perfectly fine. In actual exam questions, it will almost always say not drawn to scale, not drawn accurately, just to stop you from taking a ruler or a protractor and measuring them for yourself. You have to do the calculations. Alright, well, if we're okay with this, let's see how you do with a quick question on this on your own. So if we just get rid of all of this to start with, I'm going to obviously leave the formulas on the left, but yeah, just clear up this space and draw ourselves a new triangle. Again, going to be pretty similar, only now this will be 33, this will be 26, this will be 24, and we're going to want this unknown angle here. Well, if you just want to pause the video for yourself to have a go, and when you think you're ready, just press play again and we'll compare. Okay, so within this question, we again have two sides and an angle, and we want a second angle. So we're going to be using the first sine rule, meaning that we can say 24 over the sine of 33 is going to equal 26 over the sine of x. We want to make sine x the subject, so we're going to times it up, then bring the other fraction on the side, just like we did in our example. So sine x is going to equal 26 divided by 24 over sine 33, which will give you an approximate value of 0.14. And then if you had just done the sine inverse of this, you would have got x being about 7.83 degrees. Okay, well, here we've just been practicing with the rules themselves. I'm not going to give you an example question exactly this style for the other ones because we're about to go on to an actual exam practice question. With this in mind, therefore, if we just scroll down and have a look at this. So we have ourselves, once again, surprise, surprise, a triangle. However, this time we know two of the angles and one side. Once again, knowing two of one thing and one of the other may get us to think about the first sine rule. However, if we read through the question carefully, because we want to be sure that we're answering the right thing, it wants us to calculate the area of the triangle. That's the second sine rule. But for the second sine rule, we're going to need this angle here and this side here, because it's two sides together and an angle between them. Strictly speaking, yes, it wouldn't have to be this side, but I personally feel this is going to be the easiest ones to work out, because otherwise you're going to need to bring in the cosine rule as well, whereas here we can manage with just the two sine rules. So, to get this x first, I've already suggested we should use the first sine rule. So in that case, that would be your 8.7 over sine of 64 equals x over sine of 49. In this case, the x that we want is already in the numerator, so we don't actually have to do as much rearranging. All we have to do in this case is get this divided by sine 49 out of there, times that sine on the other side. So you'll have sine 49 times the 8.7 over sine 64, and that will give you a line length of approximately 7.31 centimeters, if we just label that now. There. As for the angle, actually we don't need a rule for this one. We can just simply say that the angles in a triangle add up to 180. So if you were to do 180 minus 64 minus 49, that should leave you with 67 degrees here. Okay. Well, now that we know that those are our two sides and that's our angle between them, we can now do that second sine rule with half AB sine C. So we'll have half times the 8.7 times the 7.31 times the sine of 67, and this should give you a final area of approximately 29.3 centimeters squared, again centimeters squared because it's the area, and 29.3 because it specifies three significant figures.